Earthquakes. By an earthquake, there is shaking the earth. Now, that is because of plate tectonics. There can be, for example, conservative situation of plate tectonics. They can stand the plates like that together, and then suddenly they want to move to the sides through the convection movement of the heat of the magma underneath the crust of the earth, and then suddenly they're going to the side, and that causes then this earthquake. It's not just one little, but it is for a few seconds. The one in Cope, which I'm gonna tell in a moment as an example, was for 20 seconds long, this shaking. Now, and that is dangerous, and what can people do? Overall, they can have an emergency kit for food and water supply, medical little assistant kit and a flashlight or things like that. Also, the government can have planned in the countries that they have fire brigade, police, ambulance, hospital, also food and water a bit stored for some time, possibilities to broadcast when the people mad should have a radio or something to then get information on what is going on. And maybe try to build earthquake-proof buildings. One idea is to have a weight on the top, which is when if a building is going to the side, counterbalances and with a computer order how to go to that side. And also to have shock absorbers at the bottom of the building, and to have steel like that through the building, not like that. So try to build that. And now the example here said in the book is the earthquake on the 17th January 1995 in the Osaka Bay in Japan. And there's the Philippine plate, the Pacific plate, and the Southeast Asian plate somehow coming together. And there are from time to time earthquakes. There was 20 seconds long this earthquake. It had 7.2 on the Richter scale. Earthquakes can be measured in the Mercalli scale on the Richter scale. The Mercalli scale isn't used so much anymore. That is measuring the destruction. 1 would be everything fine, 12 everything destroyed, 7 would be somewhere in the middle. The Richter scale, that is measuring how strong the shock wave is with a seismometer. The seismometer has a pendulum with a pen on it, and then a fixed surface, a fixed thing on the surface. That thing is moving with the shaking earth. The pen is then standing more or less, or swinging. I think the pen is standing, and then makes onto the paper these lines. And if it goes strong to the side, that would be an 8 or 9. If it goes less, a 3 or 4. And double is 10 times as strong. So 7 is 10 times as strong as a 6, and 8 is 10 times as strong as a 7. Now that had 7.2, so quite strong. For half an hour there was been afterquakes, and 5,000 people died during that earthquake. 25,000 were injured. 200,000 homes had fallen down. Houses had fallen down. 300,000 people were homeless, and there was then problems with water and food supply. A lot was destroyed of it. The elevated motorway in Kaup, a city, had fallen down, and many fires had started. Gas, electricity was shut off, and then also a lot of money necessary to rebuild the buildings, and the ones which were earthquake, they hold a little better. That is according to Geography by Jane Ferretti and Brian Gressley on the page 6 and 7. The positions and views expressed are the ones of the source and don't necessarily align with my own or with the ones of the entity spoken on. Hi and welcome. I am trying to learn seismology, today earthquakes, and after we've done that, we're going to do leg injury prevention training. And if you participate in the leg injury prevention training, then it's at your own risk. And we're talking about also about a disaster where people died. Earthquakes. Earthquakes and volcanoes are examples of natural hazards which occur on the plate margins. Okay, a natural cause of a hazard is where plates are coming together. So here by conversion, one of these plates, here wherever they're coming together, where they can't be together, it will suddenly give in and everything standing on top of it, like bumping against the table, can fall over. Earthquakes are usually the result of plate movement which is not smooth. The strain builds up along the fault line between two plates until they move, causing earthquakes. So it's all the time when suddenly they give. Epicenter, most damage occurs here, shock waves going through, focus and epicenter. The point where the earthquake starts below the Earth's surface is known as the focus. The point directly above the focus on the Earth's surface is known as the epicenter. Okay, where the earthquake is, so somewhere down there, it's actually is where plates are like that, and then somewhere down there it is. Yeah, there's the focus, and the epicenter would be now up here where the humans are. Measuring earthquakes. The magnitude of an earthquake is recorded by an instrument called a seismometer. Seismometer. We did the seismometer in mechanical engineering. It measures the height of the shock waves on the Richter scale. Okay, the seismometer measures with the Richter scale. So not in meters, but Richter scale. It's not saying 7 meters high, but 7. Each point on the scale is 10 times greater than the one below. This means that an earthquake with a score of 7 is 10 times more powerful than one with a score of 6. The seismometer records the earthquake vibrations with a pen on a sensitive arm, marking zigzag lines on a drum of paper. So, 7 is 10 times as strong as 6. 8 is 10 times as strong as 7. On this Richter scale, and how was it? It was a steady thing, and then a loose pendulum, and if it is now moving, the steady thing is moving with the earth, and the pendulum is standing still, and that way the pen is writing on the paper. Or the other way around, it was then a also fixed thing, and that is the idea. I don't know how it was the other way around now. We have to have height and sight and all. The Mercalli scale, which has been largely replaced by the Richter scale. So it was replaced. Richter scale is the replacing one. Measures the strength of an earthquake by its observed effects on buildings. So 1 on the Mercalli scale would only be detectable by seismographs, and there would be no damage at all. But 12 would be catastrophic with no buildings left standing. Okay, one person has said it is that strong, going wet to wet, it is a 6, 7, 8. Another person was saying how much has fallen over of a thing standing on the table. Both ideas are valid, but people say we use mostly rather the Richter scale. Precautions against earthquakes. Okay, what to do against earthquakes? Individuals. Prepare an emergency pack including water, food, blankets, first aid kit, radio talk. Okay, something packed with food, with blankets, because the heating isn't working anymore, the houses are broken down and something. First aid kit if someone is injured, and radio to know what's going on, and talk to see something. Light is off. During and after the earthquake, shelter under a table or bed, avoid stairways. So shelter under a table, a bed, something firm, and not to go in stairways, do we say. Turn off gas, water, and electricity, because the pipes can go wrong. After the earthquake, move to open ground. Authorities. Monitor the hazard so people can be warned. Have emergency supplies ready. Is it when the authorities should do it? Yes, monitor the hazard so people can be warned. Have emergency. So some people, for example, scientists who are looking if the Earth is going to do something and if it is happening. I don't really know how it works, what we can do, how fast it happens, but we can do some things. Have emergency supplies ready, so that also the country is looking that they have food and all things if there is an emergency. Make plans for shelter, food, and water supplies for emergency services. Fire brigade, police, ambulance, and hospital services. So all the emergency service should be ready to help, and also for the people who lost their homes and their means of acquiring food, water supply, and shelter. Plan to broadcast information for people affected. So to have something, radio or something, to tell the people what has happened and what to do. Okay, what is here going on? Computer-controlled counterweight on the roof, which moves to balance the effects of an earthquake. Steel frame with cross branches. A shock absorbs in the foundation. An earthquake-proof building. Okay, there's a computer-controlled counterweight on top, which moves to balance the effects of an earthquake. Okay, first, the pure architecture. In the middle, steel frames with cross bracing. So it's not standing still. A straight one would fall easily over. As something like that, not so fast, in particular, if there are more to the side other ways. And also in the ground, things which absorb the shock. And then the third idea is to have on the top a weight which is looking where the earthquake is going, where it is going to the side, where the building is going, and the weight is going to the side. I don't know if it works, but it could work. It's going to the side and then balancing out that it's not falling over one side. Long-term planning. Ensure route and rail communications are built to reduce the effect of earthquakes. ensure all new buildings are earthquake proof. So building buildings like that so that they don't fall over. That should the country do. Road and rail communication. Okay, I don't really know what maybe. Maybe to make the roads that we can balance out if we move into the side something. Maybe just a communication network. Can we predict earthquakes? Okay, that was just a question. American experts using the latest equipment can measure very small plate movements and record the strain building up. They can predict that an earthquake will occur, but not when it will happen. So the first thing, they can see very little movement. Do we say this very little movement is just because I never heard of it? Because the plates are all connected, if there's no movement happening here, there was an earthquake here, does it not mean that it is more likely that now at the other side of the plate something was moving? Now if someone is looking at something, if it has gotten here further, now it's obvious that now on the other side will be an earthquake. Now whatever, there can be slight movement on one side, maybe we're measuring a bit, maybe in California there's a little movement, and we know if it moves a little bit further here, all the energy will be here, and then Japan will be an earthquake, or something. Whatever, they can monitor very little movement, and we can measure strain building up. So we can measure where strain building up, one day it will come. They don't know when, but they know that. Case study Cope Japan. We don't have time. Okay, that's what we do the next time. I just want to know what we mean with that. Effects of earthquakes in LEDCs. I want to know what LEDC is. Now, if you were here for seismology, or whatever, seismology, you can go directly to the next part of seismology. There we're going to read the second page. If you stay here and participate in the leg injury prevention training, then it's very obvious. Have a good standing leg and swing your leg in front and to the side. And the other foot in front and to the side. And one foot in front and back. And the other one in front and back. And one leg up to the outside, the leg in, out into the middle and down. Our leg up to the outside, the leg in, out middle and down. One leg to the side and lift it off the ground and place it again onto the ground. With the other leg. And one leg straight out, pull the toes in, and up, point with the toes down. Out, straighten, in, up. Change the leg, out, pull the toes in, up, point down, down. And one leg out, pull the toes in, move the foot from right to left. Other leg out, pull the toes in, foot left to right. And one leg up, hands out, go over to one side with the hands, and to the other side. Middle and over, middle and other side, middle and down, other leg up, go over to one side, and to the other one. Over cross with both, middle and down. And one hand on tummy, one on lower back, and lift one leg in a straight line up. Try to bring the leg higher and pull the toes in. And pull the leg up. The other one. And now one leg up, press up. With the other leg. Stand good on one leg, turn over to that leg, down into the knee and control it over to the other side, and then up. Change the leg, stand good, turn over to that leg, down into the knee, over to the other side, and up. Stand good. And reach always with the heel to imaginary 90-minute intervals of an imaginary dial. And with your leg, 12 o'clock, 1:30 and 3, 10:30, 9, 7:30, and 6 o'clock, 4:30 and 3. And when heel onto the ground, don't do it if you're pregnant. Lift the heel off the ground, place it again onto the ground. Other leg. And one leg up and down. And we are open. The toes are pointing to the outside, in the arms up. Out, sink down. Hands onto the ground, cover the back up. And roll slowly, around back up at the top of the backwards. In the arms up. Out and down. Hands onto the ground, cover the back up, and roll slowly up at the top of the backwards shoulder. And one leg in and out. And then, if you like, and can, with the whole body. And with the other leg in and out. And then with the whole body. And another one. Arms to the sides, one leg up. Lean the front, leg up, and again down. Square the hips. And again, leg up, and back. And the last time. And now up, and pull the knee in and out. And back down. Other leg up, knee in front. And down. And again up, and pull the knee in. And back down. Legs to the sides, really bring it up. In and out. Out, in, and close the legs. And out. That was the leg injury prevention training. I thank you very much, and